Use mesh current analysis to find the branch currents IA to IE. Okay, so a circuit is given. Eventually, we want to find the branch currents, but we do the first, basically mesh currents, and then we go from there. So we have 1, 2, 3, 4 meshes, but as we see, one of the meshes, there is a current source that is only one of the meshes. So therefore, the mesh current here would be 19. So I just put 19 here. And then I will just name the other one, label the other one, I1, let's say, I2, and I3. Okay. Right. Very good. So let's write the KVLs. So mesh 1. Start from here. Negative 4ID plus 10 times the current. The current of that, see, I1 is going this way. So I1 is for the whole mesh, right? I1 here, and then I3 from this mesh going the other side. And then 5 times the current, again, I1 minus I2 equals 0. Okay, very good. And so that was the mesh 1. Now, when I look at mesh 2, I see a current source here, and its current source is shared by 2 meshes, 2 adjacent meshes. So in this case, as we saw in other examples as well, we can consider a super mesh. Okay, so we go around basically this. Oh, I don't know why my marker doesn't work. Wrong. Oh. Anyway, so let's do the super mesh. Super mesh. There's something wrong with my word. Nope. Okay, so let's just start from here. 5 times, what is the current? I2, this is my direction. I2 minus I1 plus 10. I'm going this way. So I3 minus I1 minus 240 volts. And then the last term is 40 times going down, up. So I2 is in my direction. I2 minus 90. Equal to 0. Very good. So first equation, second equation. And let me see if I can do the super mesh. So I'll mark the super mesh. So this was the super mesh. Oh, for some reason it doesn't like me to mark this. I have no idea. But this is super mesh. No. Okay, so anyway, so the super mesh started from here all the way here. Okay. Now, so let's see. I1, I2, I3, and there's an ID. So look at ID. The current of ID is in the exactly equal to I3. Hopefully everybody agrees. So ID here is equal to I3. Okay, so I can clarify that. And also on the this current source, the value is 2IB, which is equal to I3 minus I2. So these are the added equations that we have. One is this. The other one is that current source 2IB is equal to I3 minus I2. Okay. But what is IB? So I also know IB is equal to, from here, this is IB. So IB is in the direction of I1 minus I2. I1 minus I2. Okay, very good. So this combined gives me one equation. And then I had one equation here, except instead of just ID, I replace it with I3. Okay. So therefore, this is my first equation, only in terms of I1, I2, and I3. And then this is the second equation in terms of I1, I2, I3. And now this is my third equation. So I1 minus I2 equal to IB, but then IB is also that. So let me just rearrange it. So combining these two, I get twice the IB, which is I1 minus I2 is equal to I3 minus I2, right? So that's my third equation. So 1, 2, and 3. Now let me arrange these equations, 1, 2, and 3. And then we'll put it in a matrix format. So I1, from the first equation, we have 5I1, and then we have 10I1, so 15 I1 plus I2 times -5 plus I3 times. So for I3, I have a -10 and -4, -14 equal to 0. So that's my first equation. From the second equation, I1 times. I have a -5 and -10, -15. I1 plus I2 times. I have 5I2 and then 40, 45, I2, and then I3 times. I have a 10. I3 is equal to 24 plus 40 times 9. Okay, and then the last equation, the third equation, I1 times 2. Then we have I2 times -2 and plus -1 plus 2 minus I3 plus I2 equal to 0. Okay, so therefore the matrix that we write will include this number. So the first row, 15, -5, -14, I1, I2, I3, and then -15, 45, and 10, and then 2, -1, -1, 0, 0, the value there. Let me calculate it. I just put it here, 24, 240 plus that 140 times 90. Okay, we can solve for I1, I2, I3. So this is the matrix format. And after finding I1, I2, I3, you can go back here because originally they wanted us to do the branch currents. So let me just write the relationship. So IE is equal to IE is this current is equal to I1 based on the mesh currents. IA is 19 minus I2. And then IB is I1 minus I2. IC is I1 minus I3. And ID is equal to ID. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, very good. So this is a relation between the branch currents and the mesh currents.